Good day everyone. Welcome once again to our class in Math 051 Engineering Calculus 1. This is part 4 of our review of functions. So today we are going to focus our discussion on rational functions. So what are rational functions, or what is rational function? A rational function is defined by this expression here, f of x equal to g sub x divided by h sub x, where g and h, meaning this one and this one, are polynomials. For example, if you have this f of x equal to 4 minus 2x divided by x plus 3, so this is polynomial. Okay, the number of terms is more than 1, so this is considered polynomial. We also have another example, g sub x equal to x divided by x squared minus 4, h of x equal to x squared minus 9 divided by x minus 2. Okay, so this is not polynomial. Okay, so this is polynomial, this is polynomial. So if the term contains more than one, if it contains more than one term, then it's considered as polynomial. So the domain consists of all real numbers except the zeros of the denominator. So what does it mean? Whatever is the value of x that can make this denominator equal to 0, so that is not included in the domain. So that's why we have here except the zeros of the denominator. So the values of x that can make the denominator 0, so that is excluded in the domain. Here we have x squared minus 4. So what value of x that can make the denominator 0? So this would be plus or minus 2, right? When this is minus 2, so minus 2 squared, positive 4, minus 4 is 0. Or if this is positive 2, positive 2 squared, that is also 4, minus 4, that is also 0. So plus and minus 2 are excluded in the domain for this function. Here we have x minus 2, so the value of x that can make this denominator 0 is 2. So 2 is excluded in the domain. So this is the meaning of the statement, that the domain consists of all real numbers except the zeros of the denominator. That is the value of x that can make the denominator equal to 0. So the graph of a rational function has a vertical asymptote at the value of x where the denominator is 0. Right? The graph of a rational function has a vertical asymptote at the value of x where the denominator is 0. So that is what is meant by asymptote. So asymptote is the line where the function is getting closer to but it will not touch. Alright? Now the graph has a horizontal asymptote or oblique asymptote based on the following rules. Okay, so if the degree of g is less than the degree of h, then the value y equal to 0 is the horizontal asymptote. So degree of z or g. So we have this expression f of x equal to g sub x divided by h of x. So degree means the exponent of the variable. Okay, for example, if you have here x, so the degree of this one is understood to be 1, meaning the exponent of x is 1. Here the degree is 2, the exponent of x is 2. So that is what is meant by degree. So if the degree of G is less than the degree of H, then the line y equal to 0 is the horizontal asymptote. So in other words, in this example, so since the degree of G, this is our G sub x, this is our H sub x. So when you compare the degree here is 1, the degree here is 2. So therefore the degree of H is less than the degree of, the degree of G is less than the degree of H. So we can expect that the line y equal to 0 is the horizontal asymptote of this function. If the degree of G is the same as the degree of H, then the line y equal to k is a horizontal asymptote where k is the quotient of the leading coefficient or leading coefficients. If the degree of G is greater than the degree of H, then the graph has an oblique asymptote. So the first one here is a horizontal asymptote where k is the quotient. The horizontal asymptote is the line y equal to k, where k is the quotient of the leading coefficients. These are the example. So we have here degree here. This is our g sub x. Alright, so this is considered as our g sub x. And below the denominator, this is our h sub x. Now if you compare the degree, just look at the exponent of the variable x. So we have here the exponent understood to be 1. Here the exponent also understood to be 1. So we can say that they have the same. They have the same degree. So the degree of G is the same as the degree of H. Degree of G is the same as the degree of H. So the horizontal asymptote would be equal to the line y equal to k, where k is the quotient of the leading coefficients. Now if the degree of G is greater than the degree of H, then the graph has an oblique asymptote. So if you look at this, so ito yung G sub x natin. Okay, so our G sub x here, and this is also, this is our h sub x. Now we're just using the definition class, and do not be confused, this h sub x and this h sub x. So this would supposed to be our f sub x. Okay, so if you use this as our f sub x, so we have g sub x over h sub x. So if you look at the degree now, so the degree here is 2, the degree here is 1. So we can say that the degree of G is greater than the degree of H. So the degree of G is greater than the degree of H. So what is the asymptote? So the asymptote would be an oblique. So when you speak of oblique asymptote, it's a line that is not vertical, or line neither vertical or horizontal, neither vertical nor horizontal. So other than vertical or horizontal, that's an oblique. So it can be a slant line, Now when you speak of vertical, so this is a vertical line. Okay. When you speak of horizontal, this horizontal line. So when you speak of oblique, so any other position of line other than vertical or horizontal. So it can be like this, okay, or it can be something like this. So these are obliques. All right. So I hope you have understood this concept. Now, for example, sketch the graph of the function f of x equal to 1 over x. So how are we going to graph this function? As mentioned in the previous previous part of our review of function, so to graph a function, we need to, the best way is to tabulate values. No? Assume value for x and solve for f of x. So like this one. So you have x, you have f of x. So these are the values you assume for um, x. So of course, we exclude here the number that can make the divisor equal to 0. So our divisor here is an x. So what makes this function undefined? So that would be the value x equal to 0. So that's why we excluded here in the domain. Domain is the value for x, because x equal to 0 will make the function 1 over 0, or the denominator 0. That would give us undefined result for f of x. Alright, so substituting the values in this expression, so we get f of x when x equal to 1. So we have 1 over 1, so that is 1. When x equal to 2, so we have 1 over 2. When x equal to 3, 1 over 3. When x equal to 4, 1 over 4. Similarly, for the negative values, when x equal to negative 1, so 1 divided by negative 1, negative 1. Negative 2, when x equal to negative 2, so 1 divided by negative 2, so we have negative 1 half. When x equal to minus 3, so 1 divided by minus 3, so minus 1 third. When x equal to minus 4, so 1 divided by minus 4, so we have f of x equal to negative 1 fourth. Okay, so to graph this, so this is the graph of the function. So if you look at this, our g sub x here, what is the degree of g sub x? So 1, that's understood to be, yung 1 is, if you stick to the rule about the degree, so 1 is just the same as x equal to 0. Okay, so x equal to 0. So comparing their degree, so the degree of, so therefore we have x to the 0, to the power 0, divided by x. So this is our f of x. Okay, so this is 1 over, so comparing the degree, so the degree here is 1, this is 0. So the degree of g is less than the degree of h. Okay, so we have in the rule, what is the rule? As the rule says, if the degree of g is less than the degree of h, then we have, in this case, when you substitute this one, the asymptote is the what? That is the value of x that makes the function undefined. So when x equal to 0, so this is x equal to 0, so we cannot define the function here. So this is the asymptote. This is the vertical asymptote. So the line y equal to, sorry, the line x equal to 0, So, line x equal to 0, ito yung line x equal to 0 plus yung y-axis. So, this line here is understood to be x equal to 0. So, x equal to 0 is the same as y-axis. Alright? So, this is what we call the vertical asymptote. So, it is not part of the graph of 1 over x. Alright? So, that's the graph of the function. So, it's done by first tabulating values for x and solving for f of x. And then find the value of x that can make the function undefined or make the denominator 0. So, there's no other value but x equal to 0. So, that would be the asymptote. So, we have here the vertical asymptote. Okay, so y axis or the x equal to 0 is the vertical asymptote of this function. Okay, so I hope you have understood this discussion. Another example, if you are given this function f of x equal to 4 minus 2x divided by x plus 3, so we have the instruction here to sketch the graph. Okay, so to sketch the graph, you just same uh, procedure. You just look at the denominator and then find the value of the variable x that can make the denominator equal to 0. Okay, so that value is the excluded value of the domain. Okay, so in this case we have x equal to minus 3. So x minus 3 would be excluded because that will make the denominator equal to 0. So therefore, if you are going to graph it, this is our x and y axis. So this is x, this is our y, or this is function of x. So this is our y axis, which is function of equal to function of x, meaning the value of x, the value of y is dependent on the value of x. Okay, now the asymptote here, so we have, you solve the 0 of this, so we have x plus 3, so x plus 3 equal to 0. So when you subtract both sides by minus 3, if you subtract both sides by 3, so we have x plus 3. So you subtract this by 3 equal to 0. So what you did in the left side, do it also on the right side. So subtract it also by 3. So therefore 3 minus 3 equal to 0. So we have x equal to 0 minus 3 is minus 3 or negative 3. Alright, so this is the value of x that can make the denominator equal to 0. Or you just transpose, no? To make it shorter, transpose it to the right side and then change the sign. So when you transpose it to the right side, you have only x on the left side, and you have negative 3 on the right side. So you have x equal to minus 3. So x minus 3, so assuming this is our 1, negative 1. Assuming this is our negative 2. And assuming this is our negative 3. So our asymptote would be, so if you look at this, the degree of g sub x is equal to the degree of h sub x, meaning the degree here is 1, the degree here is 1, so they are the same. So according to the rule, the asymptote would be y equal to k. So that is k here is the value of x that can make the denominator equal to 0. Okay, so this is assuming it passes through 3. So assuming ito yung 3 natin. Okay, so this is our vertical asymptote. Or you have this graph. So after, of course, you have to tabulate value for x and f of x. Then plot the points. So you have f of x here. So you just do it yourself, class. Do it by yourself, or do it by yourselves, and try to check if you come up with the same graph after you plot the points. Okay, so gagawin nyo, some value for x here. Of course, yung x natin, because the domain here, if you look at the domain here, all real numbers except x equal to minus 3. Okay, so you can assume, say, you can start with minus 5 or minus 6 and so on and so forth, as long as you don't uh, include the value of x, which is minus 3. Okay, so after you put value for x here except minus 3, then you have to calculate the value for f of x using this expression here. Okay, substitute the values and then put it here. And then after that, you plot the points and then connect the points. So when you connect the points, you will get this curve. So take note that no matter how much would you make the value of x closer to 3, okay, closer this one, it will never touch this line. So the function will just go closer and closer to this line, but it will never touch. So this is the function, this one, and then it will jump up here, then continue. Okay, I hope this is clear, class. And enough for today. So we'll continue our discussion of the review of function in our next video. So that's all for now. Thank you very much and have a nice day to all of us. See you in the next video. Bye.